Good evening, everyone. My name is Adil Safa, and together with my team members Nafiz, Fazil, and Dia, we have been working on our project Bayu Drive that we hope to implement in the near future. We found that 3D printing is one of the new emerging technologies that allows ideas to be quickly implemented into the market while also utilizing materials that are recyclable. With this in mind, we wanted to generate electricity in an environmentally friendly way and cost effective way. Our project is called Bayu Drive, which translates to wind driven. Our device is eco friendly and is making use of both wind and solar energy to generate electricity. It is designed in such a way that it can fit on different vehicles such as motorbikes, then store it for further use. Lastly, the device is cheap to manufacture and affordable for low income nations. Why BioDrive? Our product and service is mainly focused on rickshaw and motorbike users, as recent studies have shown that almost 85% of households in countries like Thailand, Vietnam, Malaysia are dependent on motorbikes as a way of transportation, and almost 50% in India and Pakistan. Most of these drivers are from low income families that mostly do not have access to electricity. As studies have also shown that 350 million households alone do not have access to electricity in South Asia. Seeing this as an opportunity, we have come up with our idea to make it possible for those traveling all day to generate their own electricity by sustainable engineering. Now, moving on to Nafis.
All right. So, So thank you, Adil. This device consists of a frame that encloses a turbine. The turbine rotates using incoming wind as the vehicle is moving. The turbine's high-speed rotation is converted to high torque using a worm and worm gear. The frame also protects the turbine from heat and water from rain to reduce the wearing of the turbine through warping and absorbing water. Another purpose of the frame is to enable multiple of these turbines to be connected along a central shaft to increase the torque even when the wind speed is constant. The shaft is used to rotate a generator at a constant 2-watt rating, which is suitable for most affordable devices in the market. This enables the user to charge their device while on the go. In addition, the device is supported with solar panels on top to provide additional power in case there is no wind or when the device is idle, which enables 25 to 35% of the energy to be wind while the rest is through solar panels. The cost is based on the parts that are manufactured and the ones that are acquired externally. The frame and the turbine are both 3D printed from reusable plastics that are widely available, such as PLA. This makes the total cost of the device approximately $50. An initial investment in 3D printers is needed, which adds to the initial cost. However, this cost pays off as it keeps producing more and more of the parts in a batch process. This cost can be more easily managed through a partnership with 3D printing startups such as Azure 3DP. Now my team member Dia will give the SWOT analysis of our project.
So to understand our design more, we applied an SWOT analysis. The strength of our device is that it depends on renewable energy, it has a low production cost, and it stores electricity for later use. This will give millions of people in South Asia access to electricity without any additional cost. However, the weaknesses of our device are that wind turbines usually require a small range of functional speed. Hence, we need to operate our device in a specific range of speeds. Secondly, the DC voltage generated might require amplification. For that, we are using a DC-DC boost circuit to increase the voltage gain. Lastly, it is not easy to place on a motorbike, hence we are working on that to make sure that it can stay stationary while the vehicle is moving. The threats of our device is that if it is not shielded properly, it might be prone to humid, fire, and rain. Now moving on to Fazil to discuss the business model.
Thank you. So one of the key partners that we're looking for in this project is Azure 3DP, which is a student startup 3D printing company. Through this partnership, we want to secure a low production cost of our item. We're also looking to securing a partnership with Amazon and entering the e-commerce sector. This is a future plan that we are very confident in, as it can later prove to be one of our main revenue streams. We're also looking to forming a partnership with the government, especially in the low-income countries. And finally, this project was inspired by rickshaws. We will be looking into forming a partnership with agents in South Asian countries. The most paramount key activity for us during this project has been the design and development phase. This was done through multiple designs, material, and stress considerations. Moreover, we have also looked into maintenance of this device to increase the device life as much as possible. The key resources. The main resource for this project has obviously been the turbines that help us capture wind energy. The secondary resource have been the solar panels that are stationed on top of the device. And finally, it was the circuit and the battery system that convert natural energy into the electrical energy that stores them. The value proposition. Now, what makes our product more valuable over the conventional method is fundamentally the sustainable energy system. During our research, we did not come across any other project that incorporates sustainable energy like ours did. The closest we could find was an immobile turbine that captured wind energy and charged phones. However, it was in no condition to be put in front of a moving vehicle, which is what makes our product more valuable. Cost structure. The main cost structure for this project has been the material manufacturing cost. Thus, the material analysis was made not only based on structural analysis, but also on cost effectiveness. The research and development costs, us being students, we needed to incorporate careful research from energy, mechanical build, and circuit systems. And finally, the general administrative cost will be the licensing, shipping, and storage of the item. Customer relationship. One of our main focus is to reduce the cost of production of this item as low as possible. This is because we wanted in turn to make the cost of selling of the product as minimum as possible. Given that our target audience is generally from developing countries, this can be very key factor in developing a relationship between us and the customers. Apart from the production cost, we're also looking into ways to either remove or reduce the shipping cost, which will in return reduce the selling cost. Channels. Our main channel sources are retail and partner channels, self-service online stores, e-commerce, and conference and sales events. We're fairly looking to conference and sales event, as in conference events we can explain our product before selling it. Customer segments. Our target audience for this product is low-income household in South Asian countries, who generally tend to have more workers, especially in the rickshaw and taxi sectors. Since our item uses sustainable and renewable resources, we are also looking to selling it to green and renewable energy community. Finally, the motorbike companies, especially the ones in the rickshaw industry. And finally, for revenue streams, we are looking at public sector investment as a subsidy from the government, retail and commission, and donations from the website that we will be establishing. Thank you.